Reach into space. ABC News live coverage of the Space Shuttle Columbia continues. Now from the Kennedy Space Center in Florida, Frank Reynolds.
Okay, we're back here at the Kennedy Space Center where nothing much is happening because it all happened some 47, 48 minutes or so ago when Columbia lifted off and is now on its way in orbit and proceeding very satisfactorily. Gene Cernan is here with me, and Gene, I noticed we just received a report on the heartbeats, and it's kind of interesting. Engle's 110 up to 120 at launch, and Dick Truly's 86 up to 94.
Well, that reflects a couple things, I believe, their enthusiasm, and also the responsibility of the commander. He's got to make some decisions as to whether or not they may have to abort, and it's his decision alone if there's no other time to discuss it with anybody else.
He does have the added responsibility, sure, yeah.
But there's a guy flown into space in the X-15 16 times, and he still responds, so it's always a first time. It's never routine.
He's the veteran, and yet his heartbeat went up a little more rapidly and more steeply than did Dick Truly, but you could hardly call Truly a rookie, though. Oh, yeah. In terms of space flight, of course, they both are, aren't they, really, of actual orbital flight?
The heartbeat, I've always felt, doesn't necessarily indicate apprehension either. It's enthusiasm. It's they're ready for this, and they're there, and it's an exciting thing, like a young kid going on the merry-go-round for the first time.
What was the difference between yours on your first launch and the next time you went up? Do you recall?
I think they were as high as they could possibly go each time. Again, each time was always a first time for me. The first time I ever flew, I think they could have strapped me and blindfolded. I would have gone. I was a little bit more aware of what was happening the second and third time. But that heart rate responds to what's going on. And I don't recall exactly, but I know it was in the area that Joe was probably 110, 115.
Well, they've got quite a bit to do today, and they still have a long day of activity ahead of them. Actually, about, let's see, it's about 35 minutes or so. We should be getting the first television from the spacecraft when they will show us what is not necessarily the most exciting television, perhaps, but it will be the opening of the payload bay, which is vital to the success of this mission, because to get the payload bay opened, then, of course, they will be able to extend the arm. Of course, they got to keep the doors open most of the time during the mission anyway, don't they, Gene?
Well, there's some coolant and thermal requirements on keeping the doors open. Of course, the main mission of the shuttle, once it becomes operationally, is through the use of that payload bay, and those doors must open and close with a great deal of routineness, great deal of confidence. Of course, that's where the arm, the manipulator arm is located that we've talked so much about.
All right, for those of you who have just joined us, we'd like to reset the scene once again as best we can. We are a little more than 50 minutes into the second mission of Columbia, the Space Shuttle, and here you see it over the Indian Ocean, moving along down toward Australia.
They're probably just coming into their own nighttime, the nighttime that we won't see for maybe another 8 or 10 hours.
Mm-hmm.
The sun is setting. They don't have the advantage of seeing the beauty of that sunset because it's behind them, and they're going forward, but they will see the beauty of the sunrise.
Okay. Let's replay now, for those of you who may have missed it, the launch of Columbia 50 minutes ago.
From the other direction. Different shot. No, there it goes, there it goes.
There go the liquid engines on the shuttle, and then here will come, there's the solid boosters. You can hear the crowd. That launch is a great equalizer for commoners and kings alike.
Oh, sure.
Gene and Frank?
Yes, Jules, go ahead.
It was a spectacular view from here. You know, we actually could see the solids ignite and the liquids ignite and the solids then ignite.
You could?
Oh, sure. We're forwardmost camera position here, and whereas the press side is blocked out by the RSS, the rotating service structure, we are not.
Here's another
Now here we're going to see it
angle.
replayed again.
Yeah, sure.
This is from a camera atop our ABC camera position here.
Jules, that's a little bit better picture than we had when I was out there with you because it wouldn't lose some of the smoke away.
Gene, you know, I've seen and covered and co-anchored every one of these manned flights, and my heart was really with them this morning. It was spectacularly clear, and of course, it didn't matter whether you know Joe Engle closely the way I do, or dig truly just a little bit, the way I do, they were our guys, and they were going up to do it, and it was a very emotional moment.
Jules, you know, we all know it makes a difference whether there's people on top, whether it's a piece of hardware, whether it's got life in it, on it. Life is part of it, makes a big difference.
Well, another part that made it most interesting, Gene, was Joe Engle's unflagging modesty and sense of humor. When they landed back here the other day, he kidded with our photographer, saying, "Now, you better get it right this time. This is the last chance you're going to have."
Jules, that plume of smoke we see from the solid rocket boosters is over 700 feet long, and that's perhaps 5 times higher than the booster itself.
The acid mist cloud, if you want to call it that, blew right over our camera site, Gene, so that's one thing you missed by being inside with Frank. You've missed being...
Well, I wonder, gee, what a shot.
We'll see probably very shortly the solid rockets shut down, and it is very critical that they both depart, yes, separate and depart at the same time.
It almost looked like an animation, you know. The first television from the spacecraft will occur in about 30 minutes or so, when they will open the payload doors. And that will be very important, of course, because on this mission, they are going to demonstrate the capability of the arm, the Canadarm that is made by the Canadians and is on board this time. That's, of course, a very integral part of the space shuttle, because eventually the shuttle is to be sort of a delivery truck to take things up and, if necessary, bring them down. And the arm will be used quite extensively on that. But, however, one of the interesting things about the opening of the payload bay doors, or the cargo bay doors, is that when that happened on the first launch last April, that's when we first discovered that there had been some loss of tiles. Remember, there was quite a bit of concern about that, Gene, about whether the tiles would actually survive and stay intact so that they would be able to complete the mission and land all right.
Well, I think that's one of the things we're going to be looking for very closely on this mission again, is to see whether we were able to find where those tiles are critical and find out if we've solved the problems with losing those first few tiles. There's going to be other problems like that as we go along with the program, until we build up a system, a spacecraft, where those things that may have some failure patterns in them early will truly last for 40, 50 flights into the future.
Well, the payload bay doors must, of course, open, and they must be able to close them, too, in order to bring them down. And Steve Shepard has prepared this report on the importance and the process of the doors in the cargo bay. Steve?
The cargo bay doors down the back of the orbiter Columbia are a surprisingly complex and critical part of the shuttle spacecraft. They aren't the kind of doors you find on the side of a boxcar. For one thing, they are very large. Each of the doors is 60 feet long and 6.7 feet wide and weighs as much as 2 compact cars. They are made not of titanium or some other exotic metal, but of a graphite epoxy material, a sort of sophisticated plastic which is both lighter and stronger than metal. Attached to the inner side of the doors are 4 giant radiators. When the shuttle reaches orbit, the doors are open to expose these radiators and allow them to vent off heat into space. So much heat builds up inside during launch and from the electronics on board that the doors must be opened and the radiators exposed, or the shuttle must be brought down by its 5th orbit. Conversely, the shuttle cannot land unless the doors are closed. The doors are operated by an automatic system commanded by the spacecraft's computers. But should the automatic system fail, they can be opened and closed by hand. The astronauts train for this contingency underwater, which simulates a weightless state. In space, an astronaut would have to don a spacesuit and enter the unpressurized cargo bay. At the bay's aft wall, he would attach a kind of large socket wrench to an exposed fitting and crank the doors open or shut using muscle power. If it were necessary, the astronaut could also inspect the doors, either by traversing the inside of the cargo bay or by moving along the outside surfaces of the doors, which are equipped with handholds. In principle, doors would not seem an especially sophisticated part of any spacecraft. On the shuttle, they are.
Yes, the simple opening and closing of a door becomes a very, very important function. We are about half an hour away now from actually opening the door on board Columbia. And for more on that now, we want to go to the Johnson Space Center in Houston and Steve Bell. Steve?
Frank, the astronauts play an active role in this activating of the cargo bay door. In fact, they're getting out of their seats for the first time on this flight now that they are in their orbit for a 5-day mission. And Joe Allen is sitting here with the knowledge of someone who's firsthand gone through all this in the simulator. How difficult is it to get unstrapped, get out? What are they doing exactly?
Steve, there's a very real difference between simulator and what Joe and Dick are going through now, though, because gravity's been turned off.
Right.
And so for the first time, for any length of time, the two of them are now weightless. And one senses that as the straps are taken off. You unbuckle your seat belt, so to speak, and suddenly you're not in the seats anymore, but floating. And so right now they, for the first time, are floating out of the seats, and they will float to the back of the flight deck, and it's from that point that they will open the doors. They look back out through windows, the same view that we'll get using their television cameras, and open the door from that vantage point.
And it reminds me that on the first Space Shuttle mission, when Young and Crippen were up there, Young, looking at the view of the Earth that he had for the first time in that way, said a little bit of this could last you for about 6 months. All right, so both men have to get out of their seat. They have to get into position for the opening of the door. And it's probably worth pointing out here that if they don't get that door open, they've got a major problem because too much heat will build up in the capsule. And they might have to go back into the unit and actually have to work with that. Is that true?
Partially true. Actually, if we could not open them, we'd think twice about staying for very long.
Right.
We'd come home and fix it. We're confident enough of the doors now that we're not going to do it deliberately like we did the first time, though. We're going to basically do it automatically.
Right. Again, when Young and Crippen were up, the payload doors, they said, kind of hesitated before they opened fully, and it was Crippen who said he was mighty glad to see the doors go ahead and open smoothly because he didn't particularly care about the thought of going outside trying to do anything associated with them. So we'll be waiting for that to come up, and we'll also have some information for you on what's inside the cargo bay, the payload for this mission, the first scientific payload. And we'll continue our coverage of the Space Shuttle Columbia in just a moment. And continuing our coverage of the second launch of the Space Shuttle Columbia. It is now in orbit. It is almost completing its first orbit, in fact, and it's getting about ready time for the payload bay door opening exercise, a very critical maneuver that's going to take place here. We have a simulator of the mock-up, in fact, of the Space Shuttle at building number 9 here at Houston, and it gives us a view of exactly how the doors will look when they're opened up, the payload bay doors, but of course this time we have a scientific mission involved and we have a cargo in the payload bay doors. Lynn Scher has been investigating exactly what went into this mission in terms of the cargo and the payload bay door, and she explains to us now what's in there and how it's going to be used.
How does lightning affect the intensity of thunderstorms? How much water do dwarf sunflowers need to grow in zero gravity? Where is the ocean its greenest and thus best for fishing? To find answers to some of these questions, NASA's OSTA-1, the Office of Space and Terrestrial Applications, is sending 7 experiments on board the shuttle. OSTA's $11 million experimental package is one of the most important aspects of Columbia's second mission.
Most of the experiments were specifically selected because of their need to face the Earth. This is a model of 5 of the experiments, and it will be mounted inside the payload bay of the orbiter, just like that. And since the Columbia will be orbiting in this attitude for 88 hours of the mission, the experiments will have plenty of time to collect their data from the Earth.
The most elaborate will use a 30-foot antenna looking out the side of the orbiter to create a topographical map of certain land areas. A related project will look straight down to identify certain rock types that could indicate hidden mineral and petroleum deposits. Like almost all the OSTA-1 experiments, these will be controlled by ground personnel in Houston, and they're more concerned with working out methods of gathering data than with actual practical results. The ocean color experiment will detect algae-produced chlorophyll on the surface of the seas as a means of determining environmental conditions and concentration of food fish. Another experiment will collect data on the amount of carbon monoxide polluting the atmosphere. And there's even one that will try to develop a sensor that can distinguish between various features, the difference between snow and clouds, for instance.
While those 5 experiments are located back here in the cargo bay area, 2 others are located in the front of the craft with the astronauts.
Containers like these will hold seeds of dwarf sunflower plants with varying amounts of water in each to determine the best soil moisture for growth in zero gravity. And finally, in the only experiment to be performed by the astronauts themselves, this camera will photograph lightning by day and by night to try to determine how electrical discharges affect the violence of a storm and to determine lightning's role in predicting severe weather conditions. Like all the experiments, it's a milestone for space scientists.
So now what you're looking at is the payload bay arm that's going to be activated not at this first test of the door opening, but later in the mission. It's going to be given a test workout. Joe Allen, this is something that the pilot, as I understand it, actually is the operator and has a great deal to do with this.
Indeed he does. The robot arm is in many ways a robot, but it's in other ways an extension of the arm of the person that's working the controls.
How much practice time is going into the operation of that arm?
A great deal of practice now, although as we learn to use it, I think it will require less and less because it does react almost as one's own arm might react.
Well, it almost makes you think of these video games. Are you talking about buttons you push? Push button 1 and it moves up and right, or?
Steve, I think it's fair to say that the best training for future astronauts might be the video games as opposed to learning to fly airplanes.
But the arm then will be given a test on this mission, not to actually go out and reach outside, as I understand it, but what will be the limitation on the test?
It will reach around in many places. I'm not sure how much.
I guess it'll reach outside, but they didn't want to latch it onto anything.
We're a little bit afraid to exercise the fingers, so to speak, too much right now. We will practice moving the arm, and the next flight we will go up to something and grab a hold of it.
So we're coming up now in less than 20 minutes on the first opening of the payload doors test. And as we've said, this is a critical maneuver. We've got to get those payload bay doors open in order to let the radiators out. These are radiators that are necessary to give off the heat that builds up, that's generated inside the spacecraft from all the multiplicity of equipment in there, as well as the heat that comes from the sun on one side. That's an interesting thing that we haven't talked about, the temperature here. You've got a vastly different set of temperatures on one side of the spacecraft as opposed to the other.
Correct. We tend to think in terms of temperatures here on Earth, what's the temperature of the air? There is no air in orbit, and so temperature has a bit different sort of meaning. It's very hot on one side of the spacecraft where the sun's shining. It can be very cold on the other side.
So what do you do? Do you leave the same side of the spacecraft in the heat all the time?
If we want that side warm, we can certainly do that. In this case, the orbiter is going around the Earth. It's looking down at the Earth. So those doors are pointed down towards Earth, and the crew can look out over from their overhead windows, in other words, above them, in a manner of speaking, and see Earth below.
And it will be their first really spectacular view of the mission. Before he took off, Richard Truly talked about the mechanical arm that it's going to get its first test that was in fact built by the Canadians, and he is the man who's going to be in charge of operating it on this mission.
The arm is attached to the orbiter just outside this window and on the port side longeron. It has 2 joints, or by joint I mean a freedom of movement in the shoulder. One we call shoulder pitch and the other one shoulder yaw. Moving out from the shoulder to what we call the elbow joint, there is one joint in the elbow, which is elbow pitch. Moving out to the wrist, we have 3 joints. One is wrist roll, wrist pitch, and wrist yaw. So the combination of shoulder pitch, shoulder yaw, elbow pitch, wrist yaw, wrist pitch, and wrist roll make it just like your arm. It can reach into the far reaches of the payload bay and eventually will to grapple a payload and remove it and put it into space, or to retrieve a payload or satellite, say, that's been broken, that we'd like to retrieve, bring home, and fix it and save ourselves a lot of money.
Astronaut Richard Truly talking about the mechanical arm, and if there's just a touch of pride in his voice, well, it's deserved, because he's not only the operator on this mission, he's also helped to design it. He's been very closely involved in the development of what will be extremely important because of its duties later on when these are working missions, and it'll be putting satellites out into space and picking up satellites and other things in space and bringing them into the spacecraft for a trip home later. Our coverage of the Space Shuttle Columbia will continue in just a moment.
We are back now at the Kennedy Space Center. This is Frank Reynolds along with Gene Cernan, and Columbia, the Space Shuttle, has been off the pad now for 1 hour and 12 minutes and 20 seconds. We don't have to be quite so precise anymore because we got past that magic 31-second mark that stopped us last week. And I must say, Gene, it was a relief to go right by that and see everything just proceed right on as planned. All the last-minute glitches and worries, and even the transcontinental shipment of a part from a spacecraft that is still under construction. That's the Challenger, isn't it, out there at Palmdale?
Well, we made another major step into the testing of this vehicle so that it can truly become operational, as we hope it will.
The spacecraft is out of touch right now. They're over, well, the Southern Pacific, passing over, at the moment, some pretty exotic territory, I gather. They're over American Samoa?
Well, they passed the Samoan Islands, and that's a familiar place to me because that's where I recovered on 2 of my flights, and
really?
It's very difficult for them to see those islands. Of course, they're still in darkness over there, as a matter of fact. They'll be coming across the equator in about another, 7 minutes, I believe, and starting what we term as their second orbit around the Earth.
And when they come over the United States for the first time, they'll come in actually across Mexico, won't they?
Across the southern tip of Baja, California, central Mexico, probably just a little north of Houston if they're on a track that they had planned to be on, out over northern Alabama, Georgia, and across the Atlantic coast somewhere around North Carolina.
Wonder if they'll be able to see this place.
Oh, yes, they will. Oh, certainly. Oh, certainly. From 130 miles up, just a few hundred miles north, they'll be able, and they'll be looking for it, too, because that's... You always like to look where you've been.
All right. Now, it might be interesting, I'm sure it would be interesting to you to see where you might see it tonight. If you're in Honolulu, fine. Fort Worth, Austin, Texas, San Antonio, Texas, St. Petersburg, Florida, Miami. Just keep looking up in the sky.
If you know the right time, the right place to look, with the size and the reflective capability of the Space Shuttle, I think it'd be very easy to see. And it's exciting to see a star. It almost looks like a star going through space. Well, and you know what it is.
Do you remember going out and seeing Sputnik?
Oh, I do. I do.
Sure.
I surely do.
Across the heavens. That reminds me, the interested observers, of course, at everything that takes place on this mission will be the Russians, who don't have a shuttle but are working on one. They do have a space station, of course. And that reminds us that the shuttle, while not a military weapon in itself, does have military significance because it can carry weapons into space and it can carry other things that are important in the military sense. Our Pentagon correspondent, John McWethy, has prepared a report on just how the shuttle might be utilized by the military, which is, of course, very interested in it and has expended a considerable amount of money on it. Here's his story.
Long before America's first space shuttle roared off the launch pad, the Soviet Union was secretly working on a few surprises of its own. It wasn't long after Columbia landed safely at Edwards Air Force Base that intelligence sources began detecting a bustle of activity at Russia's launch center in Turkestan. In June, the Soviets launched a Cosmos space vehicle different than anything the West had before seen. From verbal descriptions, artists have pieced together the picture of a spaceship with more than half a dozen docking ports and mysterious pods on the outside that could cover some type of weapon. Intelligence sources speculate that the Russians may be preparing to man this complex continuously, adding more and more modules to make it seem more like home, keeping a man in space at all times. This would allow the Soviets to conduct military experiments, to have continuous military surveillance of the Earth, and to man and fire weapons from orbit. This is America's Saturn V rocket, the biggest in the world. It carried the Skylab into space in 1973. There is evidence the Soviets are now building an even bigger booster, and no one is certain exactly why. This is the runway at Cape Canaveral, where the U.S. Space Shuttle someday will land. Intelligence sources say the Soviets are also building an oversized runway. Again, no one is certain why, unless they are building a shuttle of their own. Intelligence sources say the success of America's first space shuttle flight and its obvious potential for military uses has not been lost on the Russians, nor has the fact that the shuttle program has been kept alive by Pentagon interest, and the shuttle vehicle itself modified to meet military requirements. Its 15 by 60-foot cargo bay, for example, is bigger than NASA wanted, and high maneuverability was something else upon which the Pentagon insisted, giving the shuttle the ability to change its orbit laterally by more than 1,100 miles, thus allowing it to avoid landing at unfriendly airfields in an emergency. The Air Force is building a launch and landing facility at Vandenberg Air Force Base that is just like the Cape Canaveral complex. In addition to Vandenberg, the Air Force is building its own mission control headquarters that will be located in Colorado near the NORAD Early Warning Center. In its earliest operational stages, for the next 5 to 8 years, the shuttle will be used by the military primarily as a way to get defense satellites into orbit, and, if necessary, to bring them back for repair. But the uncertainty over whether the shuttle will perform as advertised has caused the military to keep its old booster rockets in readiness, should they ever be needed. 10, 20, even 30 years out, the shuttle mission will change. By then, it could be used to carry weapons into space, weapons already under development. In the early 1970s, the Air Force used the invisible beam of light from a laser to shoot down an unmanned airplane. Now they've mounted a more powerful laser in a converted transport. All the while, laboratory tests continue.
Laser coming on. Wind tunnel coming on.
The target, titanium, the tough, lightweight metal used in fighters and missiles. The laser mounted aboard the shuttle could be used in the vacuum of space to intercept Soviet intercontinental ballistic missiles on their way to targets in the U.S. Lasers in space, in theory, could wipe out the Soviet ICBM threat.
The real use would be as an anti-ballistic missile defense system, so that you could destroy in the boost phase shortly after liftoff submarine-launched or intercontinental ballistic missiles. It also can be used to destroy aircraft flying at high altitude, such as bombers carrying nuclear warheads toward the United States.
Barring some sort of treaty that would keep all weapons out of space, most experts at the Pentagon believe the space shuttle will become an increasingly important tool for national defense, a tool that could change forever the way wars are fought on Earth.
Thank you, Jack. Well, looking at the beautiful blue sea there, it's kind of hard to think or even to recognize that one day this thing might be used in a military sense, but I guess it can be, and it certainly does have a military capability, as Jack McWethy pointed out.
Well, it's got a military potential, certainly, Frank. I don't think we as a nation can afford to bury our head in the sand and ignore the potential while other nations are exploiting the potential of space.
Tell me, Gene, you were one of the few, I gather, ever to visit the Soviet launch facilities at Baikonur. How did that come about?
Well, there were only 11 of us. I think that included Charles de Gaulle, 11 Westerners. He was not there when we were there, of course, but 10 of us working on Apollo-Soyuz flight insisted, and after a great deal of effort on our part, were allowed to go to the launch site of Baikonur, where the Soviets do launch their spacecraft and their boosters. We were given many reasons for going in at night and coming out at night, but nonetheless we were there, and we did see a great deal.
Did they answer all your questions?
No, they did not answer all our questions. They answered them in their own way, but they knew we were smart enough to know that they weren't giving us the straight answers.
I was in Moscow, I know, for the Apollo-Soyuz mission, and we made the pro forma request, knowing, of course, that it was going to be turned down. You know, we'd like to go out to Baikonur and see your launch facilities. And the answer, I guess, was something like, not possible, and that was it, and yet.
You know, we sit here and we watch all of our flights. We, the world, this country certainly, but the entire world, all of our Apollo, Gemini, all the flights before that, now the shuttle flights.
Well, they
people were
theirs.
deprived. The first flight they ever televised was the Apollo-Soyuz launch, and that was because we forced that on them, if you will. But that's the first flight their people, their own countrymen, have ever seen or participated in. That bit of history went right on through the Soviet Soviet period.
They always waited until, up until Apollo-Soyuz in '75, they always waited until everything was all set before they showed any replays of the launch. But I guess, yes, you're right, that was the first time that they actually let Soviet TV show it live, and that was primarily because it was also to be shown in the United States at the same time.
Yeah. Well, they do have a dedicated effort to permanent presence in space, and this is something I think we have to acknowledge. They recognize that the existence of space is to be used, certainly and hopefully peacefully. But nonetheless, like the oceans, like the seas, we have to consider all those possibilities that may be needed to defend what we believe in.
Well, speaking of the television, we're going to have the first television from Columbia in a few minutes. It's about 3 or 4 minutes, 13 minutes rather. Yes, about 13 minutes or so from now. Yes, at about 1:35, 1 hour and 35 minutes or so into the mission. And then we'll see the payload doors open, and we'll have a chance to inspect and see whether there's been any damage to the tiles and so forth. And we'll have all that when our coverage of the mission continues after this word from our local stations.